Hey everybody, this is the electron configuration worksheet, and we're going to need the periodic table to do this, and we're going to have to remember what we learned about orbital box diagrams. So let's get started here. So lithium is here, okay? So if we're going to do lithium, okay, we can use the periodic table to do this. We can go, let's see, 1s2, and then 2s1 if we wanted to. Okay, 1s2, 2s1. Okay. Now, let's see, phosphorus. Phosphorus is over here. It's element number 15. So I'm going to put 15 here. Okay, 15 electrons. And so when we do that, we're going to go 1s2, so that's 2. 2s2, that's another 2, that's 4. 2p6, that's 10, so I've put 10 electrons. I have 5 left to go. 3s2, 3p3. Okay, so that is, if we count 3 and 2 is 5, and 6 is 11, 13, 15. That's 15 electrons. Okay. Then we have calcium here. Okay, calcium has 20 electrons. So we can do this one of two ways. We can do this 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, or we can use the noble gas configuration. Calcium is here, so we go backwards. This is 2019, and the noble gas before it is argon with 18. So we can put argon in brackets and then start with 4s2. Okay. So now sodium. Sodium is right here. Okay. So that's 11 electrons. So we can do this one of two ways here. We can go 1s2, 2s2, 2p6, 3s1. Or, if we go backwards from sodium, Na11 is backwards goes to 10. So we have neon 3s1. Okay. Now, silicon. Silicon is 16 electrons. So that's right here. Sulfur. This is sulfur with 16 electrons. And sulfur is right here. So we can go 1s2, 2s2, 2p6. We can go 3s2, and then 3p1, 2, 3, 4. 3p4. Or if we want to go backwards to find the noble gas and do the noble gas configuration, this is 16, 15, 14, 13, 12, 11. So neon, so we can go neon, and then we'll start with 3s2, 3p4. Okay. Silicon. Okay, silicon, 14 electrons. Okay, so we're going to go 1s2, 2s2, 2p6, and then, all right, 3s2, and then 3p2. 3p2. Or again, if you want to go backwards and do the noble gas, 14. We're going to have neon, and then 3s2, 3p2. And now neon is interesting because neon is a noble gas with 10 electrons. You cannot just put neon in brackets and call it a day. Okay? It's not the way it works. So you're going to have to actually use the long form 1s2, 2s2, 2p6. Okay, 10 electrons. Neon is right here on the periodic table. Okay, and the last one is fluorine, which is 1 before neon. So we're going to go 1s2, 2s2, 2p5, 1 less electron. Okay, so now for this, we're going to have to identify all of these things. What the element is, what the energy level of the valence shell is, how many valence electrons, how many kernel electrons. Okay, so the element here, 1s2. So in order to identify the element, here's what I'm going to do. I'm going to add up all the electrons. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12. That's 17 electrons. So we look in the periodic table, 17 is chlorine. So chlorine, and we make the L a script L, and the energy level of the valence shell is the largest big number, okay? And so in this case, that's a 3. So the valence shell is 3. And then what's the number of valence electrons? That's the number of electrons in the valence shell. So if this is the valence shell, the valence electrons is 2 plus 5 is 7. And then the rest are what we call kernel electrons, electrons that are not valence. Remember, electrons have to be either valence or they have to be kernel. And so if there's 7 valence electrons, 17 minus 7 is 10. Or you can look here, and we have 7 here, and then the kernel is here, 2, 4, 10. Okay. Now the beauty of the noble gas configuration. Let's see, krypton, and so we look here. So krypton is element number 36, and then 37, 38. So this has 38 electrons, and that's strontium. Okay, so I was saying the beauty is that you get to see things a little easier here. So the valence shell, there's only one thing that's outside the noble gas. So that's 5, and the number of valence electrons is in this, so that's going to be 2. And then the kernel electrons is the rest. Okay, we know that krypton represents 36 electrons, or you could subtract 2 from 38, and we get 36 kernel electrons. Okay, so now for question 11, xenon 6s1. So xenon is element 54. Oh, a little too high there. Okay, xenon is element 54. And we come down here, so 55 is cesium. So this is 55 electrons. And so we do cesium, Cs, okay? And then the number of the valence shell here is this one, so that's 6. Valence electrons, that's electrons in this thing, so that's going to be 1. That's what that number is. And then this is the kernel. So the kernel electrons in this case is 54, because that's what xenon represents. Okay, so neon over here, okay, element number 10, and then 3s2 gets us to magnesium. So we're going to do Mg, and then the valence shell is the outermost shell. Again, that's 3. Valence electrons is the number in that valence shell. So that's going to be 2. And then the rest of the electrons, there was 12 electrons in here. The kernel electrons are the rest of them, so that's going to be 10. Okay, so now we come over here. Okay, we have to identify the element. So we go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So this is calcium, and there are 20 electrons. This, in this box, is the valence. That's the highest number big number. So the valence shell is 4. The valence electrons then is the number inside there. That's going to be 2. And since we have 20 electrons total, the kernel electrons is the rest. So 2 minus 20, that's 18. Or if you wanted to, you could count 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18. Okay? Okay, so 14. Okay, 14 goes to, now I'm going to do a little more shortcut. So it's valence here is 3s1. So I'm going to go to 3s1. That's sodium, Na. Okay. So again, this is the valence. So the valence shell is 3. The valence electrons, how many electrons are in that shell? That's going to be 1. And the kernel, or the core electrons, is all the other ones. So if you know this has 11 electrons, 1 of them is valence, so the rest, 10 of them, are kernel. Okay. So now we go back to a noble gas configuration. Argon is 18, and then 4s2. That puts us back to calcium. Oh, we just did calcium with 20 electrons. Look at that right here. So the valence shell is this. That's 4. The valence electrons is 2. And then the kernel electrons is still 18. Okay. And then this last one is 1s2, 2s2, 2p6. So that gets us to neon. Neon, so that's 10 electrons. So now the valence is all of those. So the valence shell is 2 because there's multiples with 2. The number of valence electrons is all of these. So that's going to be 8. And the kernel electrons is whatever's left. And so in this case, it just happens to be 2 electrons. Okay, so there it is. That's the electron configuration worksheet.